I'm Trish. I'm Karen's mom. This is my friend Kathy, and we met in college, my freshman year, her sophomore year, and time rolled on, and we ended up having kids. We each had 2 kids, and we used to get together and do some fun things together. What did we do, Kath?
Well, we did all kinds of science experiments, and they leaned mostly towards physics and chemistry. Our favorite one, I think, was the soap boat that involved using the bathtub, which the kids liked.
Yes, we took a piece of cardboard and we cut a little V in the back and a V in nose in the front. And you put a piece of soap in the back and the little cardboard went scooting across the bathtub. We were all surprised and thought it was a lot of fun. So now our 4 kids are all science students.
All in college?
All in college, and one's a graduate student. So I guess Karen just had to be a scientist.
So for this experiment, my brother Andy is going to blow up a balloon, normal balloon like you see every day. A little bit more, there you go, and you're going to tie it. And next he's going to take a small wooden rod like we use for our other experiments. There they are. And he's going to stick one end of them in a little bit of lotion. And what are you going to do, Andy?
I'm going to stick it through the balloon.
Isn't it going to pop?
Let's find out. I don't think so.
No? Oh! Look at that! That's funny. It popped. I guess Andy does not have the special touch.
To not pop a balloon.
Let's see if Mama Strat can successfully not pop a balloon. I think that's good.
The hard part when I was teaching science to elementary school kids is finding a little 2nd grader who could tie a knot in a balloon.
I couldn't do that till high school.
Let's
Don't
see.
close my laptop, it's running code.
Okay.
Welcome to the Strat household where we run code on our laptops in the kitchen.
Yep.
Bye.
Bye. Where'd you put the car, Mom?
Say again?
Where'd you put Karen's car?
It's returned to where it came from. Well, we'll start by putting it down this end.
Oh, you just stuck that through the balloon.
Let's see.
I can't really see it. And look at that. There is a wooden stick in our balloon. And it has not popped like Andy's balloon.
Can we get it to go out the other side?
No. Oh, almost there. Will it pop? Will it pop?
Gee,
It's a stubborn balloon.
it is stubborn, isn't it?
Oh.
There you go.
And there we have it. A wooden rod through an entire balloon. Ta-da! Quick. Taking a video. Oh,
Why?
Why are we posing? My eyes? Don't take a video of this. You're gonna
Oh,
make a face.
nice shirt. I like it.
Thanks. Got it
In University of Maryland.
in junior year of high school.
At the physics conference you went to?
Yeah, it was a place called Physics is Fun.
Yeah.
And they would have all these little experiments and stuff, and we would get extra credit in my physics class for going. And I never told you this, but I drove more than one person to Maryland to go.
I thought Claudia drove.
Nope.
And you ended up in Baltimore.
Claudia?
Action!
For our next experiment, we have a few special guests joining us on this lovely Thanksgiving day.
Who do we have?
Over here, we have Miss Kathy Kilmeyer, who went to college with both of my parents. And she's not my mother's oldest friend, but she's known her the longest.
Did she graduate?
I did, believe it or not.
Okay.
Yeah.
And over here we have Mr. Ray Karlstrom.
Hello.
I played soccer with his daughter when I was 4 years old, and we've been good family friends ever since.
That's really putting it in perspective. Okay.
So for this experiment, We have a lovely selection of cans. We have some cream soda, which my brother, thank you for drinking this today.
Point the camera at your brother.
Yeah, I pointed it. Show it,
Oh.
Andy.
Oh.
Hi, thank you.
Okay.
And then our next size, we have some Sparks, which I had to drink. And we also
Had
have
to.
some Four Loko, which my father helped me finish last night. Also, thanks, Dad. So what we're going to
My
do...
pleasure.
These have a little bit of water in it, just filled up about this far. So we're going to turn on the stove.
Ah!
See, that's a little troublesome.
Woo!
Woo! We need a little more water.
There's still one more guest you haven't introduced.
You?
Your assistant in the green shirt.
Oh. They already met her. She blew up the balloon and just
She
popped
blew
it.
up. She blew up yesterday.
So we're just going to heat up this water until it's steaming.
How can you tell?
I
Can
guess
you hear
you'll
it?
see, hopefully see some steam coming out.
Is the house gonna blow up?
It might.
I
Alright.
All right.
Is it time?
don't think it's
All
ready.
right.
No, it's not ready.
I hear it.
I think it's ready.
I can hear it. It's talking to me.
Ready?
That's your dinner.
Yeah.
Okay.
I don't see any steam. Oh! You broke it.
Looks like I just squeezed it. Really?
Man up.
This has been heating up for a few minutes now.
Man.
Quick, get it.
No, not. Laura's got some. Well, that was a good experiment. There it is.
Psychology experiment. We need gloves.
That was good. And we don't know how hot it is. You got a hot hole?
We are rolling.
So we're on to our third method of trying to get this can to implode.
And what is that?
And right now we have the can sitting in a pot of boiling water. So the point of this
And what's
is...
in the can?
I was getting there.
Oh.
The point of this is that all the air molecules inside the can are heating up, and as the molecules are hotter, they hit off each other faster and they spread out. So essentially, a bunch of molecules will be exiting out of the top.
Is there any beer in the can?
I wish.
No. So in other words, no beer will be destroyed in the course of this experiment.
There will be no alcohol abuse.
Yeah, don't abuse the alcohol.
Someone else, can you do this? I don't want to kill Kathy.
That's an author move. You didn't get quite in.
Sometimes
Didn't
it's
go
really
fast
loud.
enough. Yeah, I remember the loud ones.
Eric, maybe they're making cans differently
again?
now.
Cranberry juice?
Have you seen this one yet?
Nope.
Is it filming?
Yep.
Oh, all right. For our next one, we have a tea candle, which I'm going to put in this little metal holder. And I'm going to place this into, this is just water with green food coloring so you can see the water a little better. And I'm going to find my matches. And, oh my goodness. Okay. So we all know that when fire combusts and it consumes oxygen. So once this is lit, there we go. So right now it's taking in oxygen and therefore it's producing fire. So if I cover it like this, there's only so much oxygen that's left in this glass, and it's going to consume all of the oxygen, and therefore it's going to create a vacuum. So I'm going to place this on top of the candle. And if you look on top, it pressed out all of the water. You can see straight through to the candle, and the candle's slowly fading out. And alright, so now the candle's out, so it used up all the oxygen it possibly could. So it created a really big vacuum, so I can actually pick up, if you look from the side, I can pick up this whole thing just by the glass. And which really isn't what was supposed to happen, but it's still kind of cool anyway. So if you can look on top, I'm going to tilt up the side. It's stuck on there pretty hard, but it squirts water really hard. So yeah, But we'll try to do this again so we can show what it was actually supposed to do, because I wasn't really supposed to be able to pick up, why are you so close to me, pick up the entire thing. So let me dry this off, or I could just hold it at a, ooh, that was close. I'm just going to hold it right here so it's not touching the bottom, but there's still more, there's closing off all the oxygen that's getting into the candle. So if you look from the side angle now, go from the very side. You can see it rise up because it made a vacuum, and because the oxygen decreased, that's how much gas. You can see from the bottom of the glass how much liquid was sucked up. That's how much gas was consumed by the fire that was burning. So now our candle is now floating, and if I lift it up, it drops back in. Well, that's all we have for today. Thanks for watching another episode of Kitchen Science with the Strapp family, the Thanksgiving edition, where physics is always fun.